Okay, here we go. This is just going to be me working through a few examples. So if you watch the video or look at the notes, this is something that you probably have already learned how to do in Algebra 1 or Algebra 2. But we're just talking about how to shift a graph up and down or left or right. And that's done by adding or subtracting. Okay, so the first thing I want to point out is, back when you did slope-intercept form, that this is a graph as a slope of 3. And there's no number added or subtracted. So that meant its y-intercept was 0, went through the axis as 0. And you know that if you were to add 2 to that, it shifts the graph up 2. Or if you were to subtract 3 from that, it shifts the graph down 3. So that's true of all functions. Let's look at, for example, y equals x squared minus 3. All right, so if we're going to graph that with a parent chart, we're going to think about what x squared looks like. So it's -2, -1, 0, 1, and 2. And then when we square each of those, we get 4, 1, 0, 1, and 4. So that'd be the graph of x squared, but we want to subtract 3 after it's been squared. So this first step is x squared. Now, after that, we need to subtract 3. So I'm going to write a little -3 up here to tell me 4 minus 3 is 1. 1 minus 3 is -2. 0 minus 3 is -3. And then these are going to be the same two values as above. -2, 4 minus 3 is 1. So these are the y values that I get out of the function. These were the x values that I started with. So we can see if we come over here and graph this, and use kind of a bigger scale here, that 0 goes through -3, and 1 and -1 go through -2. So 1, -2 is here. -1, -2 is here. And then at -2 and +2, it equals 1. Here and over 2 and up 1. So we get this graph. And we can see things like the domain is still all the real numbers. The range is here from -3 to infinity. We've learned that this left side is decreasing from -infinity to 0. Over here, this is decreasing. And the right side is increasing. So it'd be increasing from 0 to infinity. So trying to remember some of those things that we talked about from the first section. We also want to be able to tell if it's an even or odd function. So see how it has symmetry over the y-axis, and also it has an even exponent. Actually, both of them have even exponents because this is x to the second and this is -3x to the 0. All right, so this is an even function. Okay, it's symmetric to the y-axis. All right, so let's look at another one where we're shifting to the left or to the right. So in this one, I'm going to look at a different function. Let's say we look at y equals the absolute value of x plus 3. And so here it's a little bit different because the adding is happening before I do the function, before I do the absolute value. And so notice that up here, if it's in parentheses there, x minus c or x plus c, and then you do the function, it's going to end up shifting the graph to the left or to the right. And it kind of behaves in the opposite of what we think. We usually think that if we add, we go right. If we subtract, we go left. But actually, subtracting is going to shift it to the right, and adding is going to shift it to the left. And we'll see why. So think about absolute value. You could put any numbers in, and it makes those numbers positive. So what the key is to remember that the number I'm taking the absolute value of, okay, over here, this is the absolute value. Now, what's happening here is I'm adding 3 to a number, and then I'm taking the absolute value. So these numbers are what I've taken the absolute value of, these x's. I have to think about what is the number I would put in for x, so that when I add 3, I would get this -2, okay? So if I want to add 3 to get +2, for example, I have to think about how would I go backwards, and that would be subtract 3. And so I don't know if you've ever thought through it, but that's why we do the opposite here, is that we want, so for example, 2 minus 3 is -1. Now let's look at what happens. If I put -1 in there and I add 3, going this way, I get 2. I take the absolute value of that and I get 2, which means the point -1, 2 is going to be on this graph. There's my y values. So I do the rest of that with these other ones. 1 minus 3, 0 minus 3, -1 minus 3, and -2 minus 3. These are my x values. So 1, 2, 3, 4, 5. And we're going up 1, 2, 3, 4. Okay, so -5 is up 2. 1, 2, 3, 4, 5, and up 2. -4 is up 1. Then I have -3, 0. -2, 1. And -1, 2. So I have this graph. So notice it shifts it to the left. Okay. Our domain's all the real numbers, and our range is still 0 to infinity because it didn't shift it up or down. It shifted it left and right. What does change is where it's increasing and where it's decreasing. It used to decrease to 0 and increase after 0. Now it's decreasing from -infinity to -3. And it's decreasing there. And it's increasing from -3 to infinity. Now, even though this graph would be symmetrical to -3, it is not an even or an odd function. It doesn't have symmetry to the y-axis, or it doesn't have symmetry to the x-axis. Okay, so we'd say it's neither even nor odd. All right, so let's look at one where we are going to do both. So oftentimes the function is going to be shifted up and down and left and right kind of all together. So let's look at this one. Maybe we'll look at the cubing function. X minus 2 cubed plus 3. So if it's got both a shift here and a shift here, that's going to move it in 2 different directions. The plus 3 out here is going to move it up 3 units. And again, remember this -2 behaves the opposite. Doesn't move it to the left, it actually moves it right 2. And then this cubing tells us the basic shape of the graph is going to be something like that. But it's going to move right 2 and up 3. So let's look at how we would do that. The x values here, we usually stick with -2, -1, 0, 1, and 2. But now we're cubing those. Okay, so when I take 2 times 2 times 2, I get 8. 1 cubed is 1, 0 cubed is 0. Here I keep a -1, because -1 times -1 times -1 gives me -1. And then -2 cubed is going to be -8. So that's my starting function. And it doesn't really matter the order that I figure out the changes here. I'm going to start with this one. This is what happens after I cube it. I have to add 3. So over here I'm going to put plus 3. So I cube it. The next thing that happens at the end is I need to add 3 to everything. So that's going to give me -5, +2, +3, +4, and 11. Those are my y values. But I'm not plugging in 2 to start with. See, if I plug in 2, I would get 0 cubed. Okay, so that's actually going to go right here. If I plug in 2, I get 0 cubed. Why is that? It's because I'm subtracting 2 from everything. So how do I go backwards and get my starting values? That'd be to add 2 to everything. So 2 plus 2 is 4, 1 plus 2 is 3. I already did 0 plus 2. Negative 1 plus 2 is 1, and negative 2 plus 2 is 0. So these are my starting values, and we can follow any one of them through. If I plug in the value of 2, 2 minus 2 is 0, 0 cubed is 0, and 0 plus 3 is 3. Okay, so let's look at those on the graph. So I've got 0, 1, 2, 3, and 4. And then over here, you can see that I would need to go from negative 5 to positive 11. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, way up here. So 0, I'm at negative 5. 1, 2, 3, 4, 5. And then at 1, I am at a positive 2. At 2, I'm at positive 3. And at 3, I'm at positive 4. Almost looks like a perfect straight line. But then at 4, I'm clear up at 11. So that's that basic shape that we're talking about, kind of that looks like a straight line in the middle, but then it sharply moves up and sharply moves down. It's going to come down like this and then come down like that. We've got all the real numbers for our domain and our range. This is usually an odd function, but notice that it's not symmetric to either the x or the y-axis or the origin because it's been because of where it's been shifted. So we would say, again, neither odd nor even. And then think about it. What do you think? Is x, are the values of the function increasing or decreasing? As I move to the right, they are increasing from negative infinity to positive infinity over the whole domain. All right. Okay, let's see. What can we end with? Let's look at one where it's maybe written a little bit differently. Let's try y minus 4 equals radical 2 plus x. Y minus 4 equals radical 2 plus x. So you might notice a couple things. The y is not isolated by itself. So the first thing I'll probably want to do is add that 4 to both sides of the equation. So we get y equals radical 2 plus x. Now we know that the addition right here, it doesn't matter what order we add. So some people are used to seeing it as y equals radical x plus 2 plus 4. But those are the same thing. All right, so what's going on? We recognize that here, the function we're looking at is the square root. So that means my graph is going to look like kind of a sideways half of a parabola. It's going to look like that. I'm going to have a starting point. This plus 2 happens before the function, so that's the left and right. And since it's positive, it's going to behave the opposite and move it left 2. And then the 4 happens after. That's going to be up 4 units. So let's go ahead and find that. You guys make sure you silence your phones. That's going to be distracting. So over here, let's do our parent chart where we do x and y. Now with the square root, this is one where we always put in numbers that we can easily take the square root of. 0, the square root of 0. 1, the square root is 1. 4, the square root of 2. And one more. Let's do 9. So we get 0, 1, 2, 3. Those are our square roots. So this plus 4 right here, this happens after I've taken the square root of everything. So after I take the square root, I add 4. So 7, 6, 5, 4. Those are my y values. Now here, before I take the square root, notice that I'm adding 2 to everything. I added 2 and I got these numbers. So what number do I add 2 and get 9? That's 7. Right? So back here, to go back, I have to subtract 2. So 4 minus 2 would be 2, 1 minus 2 would be negative 1, and 0 minus 2 would be negative 2. Those are my x values. So I'm ready to graph. So I'm going to go back negative 2 and up 1, 2, 3, 4. That's the start of my graph, like over here. And you'll see that shape just fill in as I put in the next ones. So negative 1 is at 5. And then I go over to positive 2, and it is at 6. And I'm going to hit 7, clear out here at positive 7. 1, 2, 3, 4, 5, 6, 7. So I have that nice kind of curve. I missed my point there. Wasn't too great. All right, let's finish this out. Domain, it is going to have a bracket because it's going to start at this value, negative 2 to infinity. Range is also going to start at this value, but it's going to go up towards positive infinity for y. So here we got 1, 2, 3, 4. And so these starting 2 points, you'll notice that the domain starts with this first x value and the range starts with this first y value. It's neither, has no symmetry. And does it have, is it increasing or decreasing? Well, you can see as we move to the right, it continues to increase from the whole domain, negative 2 to infinity. Okay, that's a lot of just examples. Hopefully that's great and it's enough to help you. And that'll be it for today.